This tutorial I'm going to go over physics exam number 8. Josh, who is 50 kilogram, his crouches height and who is jump height 0.7 meter. What do you want to know? When in order for him to jump up, he had to push the earth. We are not asking for pushing force. Some of you really found the pushing force. That's not what we try to find. We try to find the net force acting on him or net force acting on the earth. If you find the net force acting on him, that's fine. If you find the net force acting on earth, that's also fine, because they all are equal in magnitude, opposite in direction. If you find the net force acting on Josh, you just write it down and put a negative sign in front of it, and that should be the answer. Okay, so 0.3 and 0.7. okay, so what happened? This is BF squared is equal to BI squared plus 2AD. So V is equal to because I want to do it quickly. This is 0. This is VI squared. You are trying to find it to let's say negative 10. D is equal to 0.7. So V is equal to 20. So 14. So V is equal to square root of 14. Square root of 14 is 3.7 meter per second. Okay. All right. So now we are trying to find the acceleration. VF squared is equal to VI squared plus 2AD. So 3.7 squared is equal to 0 squared plus 2. Acceleration you try to find crouch height. So acceleration is 22.87 meter per second squared. All right. Let's explain what's happening over here. He crouches 0.3 meter. His jump height is 0.7 meter. Okay. You can call A, B, and C. Really, you need to understand this problem because you're going to see it many more times in the exam I give you in the future. So this is at location C. This is location C, and this is location B. Okay. So the velocity at location B. And this is location B, and this is location A. Okay. And this is acceleration at location B. Okay, so far so good. Now let's draw some free body diagram using Newton's third law. Josh Fg is equal to mg, or you can say F on Josh by earth is equal to 50 times 10, 500 Newton. Okay, so what happened? This is equal in magnitude but opposite in direction. So Fg prime is equal to 500 Newton by Newton's third law. Now let's use that color again. Josh push the earth. Push how much? We don't know. We'll find out. If Josh push the earth push him back. So you're gonna call Fp prime. Now we can separate this. We can separate the Josh. Now, okay, we're gonna separate the Josh. This is Josh. This force acting on him, and this force acting on him. Okay. This force is 500 Newton. And this force, we're going to try to find out how much. Okay. And by the way, this one is what? F on Josh by Earth. And this one, F on Earth by Josh. Okay, so to find this one, once we find this one, we can just say they're the same thing. Well, we can do the Earth now as well. So this is the Earth. We can bring this one over here, and we can bring this one over here. We already know that one. That one is 500. And this one we're gonna find out. But let's find out this one. Okay, so Newton's second law say F equal ma. So all the forces acting on it, Fp minus Fg is equal to m is 50. We're not going to do it now. So Fp is equal to m g plus a. So Fp is equal to m 50, g is 10, and a is 23. Okay, so Fp is 50, 33. So Fp is how much? 1634 Newton. So you know this one now, 1634 Newton. Okay, now what is the net force? Net force is F net is 1634 minus 500. 34 minus 500. So F net is 1143 Newton, and that is upward direction for Josh. 1143 Newton, upward direction, F net. So this one F net has to be what? 1143, negative 1143 Newton, downward direction. Why is that? This is 1634. So positive 500, negative 1634. Okay, so you can check your answer whether it's right or wrong. Check on Josh, acceleration of Josh. See whether that's correct. 1143 divided by 50, and that should give you 23. 1143 divided by 50, and that's give you 20. That's give you 2287. So that's correct. All right, but acceleration of the Earth would be much less. Is because why is that? It's because the Earth mass is big. Problem number 2. Parachute. This is force due to gravity acting on the parachute. This is friction. Yeah, friction. So to find the acceleration, let's use Newton's second law. F net is equal to ma. Acceleration is F net over m. Let's first find the F net. So F net is equal to what? Is equal to ff minus fg. In this case, ff is positive because it's acting upward direction. So F net is 652 minus 834. So F net is how much? 182. So acceleration is 182 Newton divided by 85 kilogram. See again, acceleration is Newton over kilogram, and I'll show you why Newton over kilogram is meter per second squared. 182 minus 85, and no, 182 divided by 85, and that's 2.14 meter per second squared. And what I wanted to show you is that meter per second acceleration, Newton over kilogram, is equal to meter per second square, which is acceleration. So what do you have in Newton? Kilogram. So Newton is actually kilogram meter per second square. So Newton is kilogram meter over second square. You have kilogram meter over second square. Kilogram cancel. So meter over second square is equal to meter over second square. So what do we prove? We prove that Newton over kilogram is equal to meter per second square. Okay. And you apply the force, applied force, F applied. Okay. If you applied force is 12 Newton, what happened to the force of friction? Force of friction also become 12 Newton, as you saw in the classroom. In what scenario force of friction become 12 Newton? If the Fs max is greater than 12. What is Fs max? So this is Fa, this is Ff, this is Fs max. If Fs max is, I don't know, make up a number, 13 Newton, then 12 Newton is not enough to move this object. Remember, Fa is equal to Ff. So the moment you apply 12 Newton, the friction will also become 12 Newton. If 12, the friction will also become 12 Newton, stopping the object from moving. To move this object, you have to apply more than 13 Newton. This is 13 just example, it could be 14, 15. The car and its driver, combined mass is 600 kilogram, and the radius of the loop is 160 meter. And from loop, one revolution takes 36 seconds. What you need to find is centripetal acceleration, which is v square over r, but you don't have velocity. The car moves with constant velocity. So to find the velocity, v is equal to vit plus half at squared. Right? It moves with constant velocity. So you're going to use velocity is distance over time formula. So distance is 2 pi r, the circumference, over the time it takes to complete one loop. So velocity is 2 pi r is 160, time is 36. So the velocity is 28 meter per second. So that acceleration is v square over r. So acceleration must be 28 square over 160, and 26 square over 160 should be 4.9 meter per second square. This is his velocity, 4.9 meter per second, meter per second, and this is his force. We did not ask you to find the force. Box sitting on a frictionless table, you apply some force to move it. As angle between x-axis and applied force increases, what happened to the acceleration? Since acceleration is net force over mass, since the mass is constant, then acceleration would decrease if the angle increase. Why is that? Let's consider two scenarios. Scenario one, let's pull it with 30 Newton, 30 degree, F is 100 Newton. Okay, so then the box is, I don't know, 10 kilogram. And the scenario two, box is also 10 kilogram, but F is 100 Newton. However, this is 60. So this acceleration would be smaller. However, this acceleration would be bigger. Why is that? Because this net force would be bigger. Why is that? Because 100 cosine 30 is 50. So 50 divided by 10, which is 5. 100 cosine 30 is 87, I believe. So 87 divided by 10 is 8.7. 100 cosine 60 is 50. So 50 divided by 10 is 5. So of course 8.7 is bigger than 5. And if you increase the angle a little bigger, make the angle 90 degree, right? Acceleration at the x direction would be 0. So as the angle increases, angle is small, angle big, angle bigger, right? Acceleration decreases. So problem number 6, there is a planet named X. Acceleration due to gravity of the planet is double than Earth. An object weight is, let's say there is an object. The object weight is 980 Newton. What is the mass of this object? Newton's second law, Fg is equal to mg. So mass is Fg, which is weight, divided by acceleration due to gravity on this planet X. The weight is 980 Newton and 19.6 meter per second square. Meter per second square, or Newton over kilogram. Write it, Newton over kilogram, whatever, easy. So Newton over kilogram. So Newton cancel, 19.6. So it's 50 kilogram. So a basketball player jumps when, or George jumps, it doesn't matter. You remember George jumps, right? When you jump, right? Okay, this is your maximum height, max height. Okay, at max height, velocity is 0, of course, y direction. However, your air in this problem, given that you are in the air, 0.8 second. So what time you are at max height? 0.4 second. Here is 0 second, here is 0.4 second, here is 0.8 second. At 0 second, you take up. At 0.4 second max height, at 0.8 second, you return to the ground. Okay, so the 2 steps. Vf is equal to Vi plus At. We want to find the max height. Vf is 0. Why is that? Because Vf is 0 at max height, always, no exception. Vi is that what we find, minus 10t. T is 0.4. Okay, so Vi is 4. Okay, how that gonna help us? Vf squared is equal to Vi squared plus 280. Again, Vf is 0 at the top when the max height, because we are trying to find the max height. Vi is, we just found, 4 squared is 16, minus 10 times 2 is 20. So D is equal to 16 divided by 20. 16 divided by 20 is 0.8. 0.8. So you have to find the close to, if you use negative 9.8 instead of negative 10, you're going to get 0.78. So problem number 8, there is an object called object A, and there is an object called object B. So A, instead of A, we can call 1K mass, and it's called 3K mass, right? Both of them exposed to the same net force. So this is this one approaches to same net force. How much net force acting on this one? or let's put this way, net force. Net force, I don't know, 10 Newton. Net force, how much? 12 is a better number. 12 Newton. Okay, so the acceleration, this one acceleration would be 3 times less. This one acceleration would be 3 times more. So remember, acceleration is F net over mass 12 divided by 1. So this is 12 meter per second square. Acceleration is F net, which is 12 over 3. Acceleration is 4 meter per second square. Okay, this is 3 times less than this one. So if mass increases, big mass, small acceleration, small mass, big acceleration, and that is called Newton's second law. Mass is inversely related to mass go big, acceleration go small. Mass is inversely related to acceleration. Okay, so Newton's second law. The field, this is, we want to find the field on ISS, which is 400,000 kilogram, 254 miles from the surface of the earth, which radius is 3 times 10 raised to 6, 6.37 times 10 raised to 6 meter. And the force on ISS by the earth is 6 times 10 raised to 6 Newton. What do we need to find? This G. You know that as G and radius, if the distance increases, radius decreases. Over here is 9.8. Okay, so over here, if the ISS would be here, is 9.8, not 9.8, less than 9.8. How much less? That's what we are trying to find. Okay, so this is, I believe this is 4. This is 3.62 or 4. All right, so what was going on? So this is R1, this is R2. This is SI unit, this is not SI unit. So 254 mile times 1 mile is equal to 1.6 kilometer. 1 kilometer is 1000 meter. Mile cancel, kilometer cancel. 254,100 times 1.6. So 254 times 1.6, and that is 406,400, and we have 6371234, and then 406,400, 0046776, 6.8 times 10 raised to 6. So this is the distance, 6.8 times 10 raised to 6. You don't have to do this hassle, because you can do two ways. You can do F is equal to mg. So the easy way is this. G is F over m. This F is 4 or 3.62. Actually, let's use 4. 10 raised to 6. Mass is how much? 400,000. No, let's say 4 times 10 raised to 1, 2, 3, 4, 5. Wow, cancel. But that's lead to a problem, is that you're not going to get the precise answer. So this is, let's use the actual value. 3.62. And let's use the actual value. What is the actual value? I believe actual value is 419725. 419725. And this is 3.62, right? Yeah, 3.62 times 10. Okay, so we're going to use the actual value. So F is equal to mg. So we want to find the field. F is 3.62 times 10 raised to 6. And this is 4.19725 times 10 raised to 1, 2, 3, 4, 5. All right, 3.62 divided by 4.19725, 0.86 times 10 raised to 1. So G is 8.6. So this is one way, Newton over kilogram. The other way is Fg is equal to Fg. So mg is equal to mg. Oh, well, no. M1, this is the M, mass of the satellite. G, M1, M2 over R squared. MM cancel. So G is 6.67 times 10 raised to negative 11. The mass of the Earth is 6 times 10 raised to 24. Radius, we just found it. How much? Hopefully you did not do anything compromise with the distance. 6.8 times 10 raised to 6 square. So G is 6.67 divided by times 6 divided by 6.8 squared times 10 raised to negative 11 plus 24 minus 12. So 6.67 times 6 divided by 6.8 square. No. 6.67 times 6 divided by 0.86 times 10. So G is equal to 8.6. Who should we expected? Newton kilogram. How did we expect that? Because the graph is, look, if this is A, this is B, this is C, A to B, okay, and this is what? From here to here is the earth radius. Here is the infinite, okay, and this decreases. Projectile has a horizontal component 15, a horizontal component of the velocity, which is 15, and vertical component of the velocity, which is 25 meters per second. And the projectile is in the air 5 seconds. You want to find the range from here to here. This is called range. You cannot use the range equations because the angle is not given. Well, you can find the angle, but there is a better way to do it. This is equal to VIT plus half AT squared. At the x direction, there is a velocity. Acceleration, was that mean? At right here, this is also 15 Vx. Right here, this is also 15. Vx never changes because this guy is 0. All right, so this is x, this is x, this is 0. Okay, what do you find? Vix 15 times 5, so which is 75 meters. And that's all. There it is. That is problem number 10. Vectors. Let's do x-axis, then I can explain this one. X-axis. This is, I'm going to remove the x and y-axis. So I gave you the vector A. Vector A is 30 degree, negative 30 degree. I'm not going to measure. If you take a protractor, you will see that this is This one is negative 30 degree. I'll do it again. Negative 30 degree. I cannot. Okay, negative 30 degree. This one is 20 degree. The resultant is 20 degree. Resultant is 20 degree. This is vector A. This is the resultant, and this is vector A. All right, so you can remove. Now I'm going to remove the x and y axis. Okay, which one is the B? Why don't you do parallelogram? Make sure you use ruler to do that. To do the parallelogram, so this is A. We are trying to find B. So this is B. And this is B prime. Alright, so answer is this one. So next time you're going to use the protractor, see that what degree with respect to x-axis. Pretty easy. Sitting on a table, you want to move it. To move it, you apply force. And so I gave you graph. So here's the graph. This is how graph look like. This is force of friction, and this is time. And this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.2, and so on. I'm going to move it here. And this is, let's say, 1 second, 2 second, 3 second, 4 second. Okay, at 1, interesting thing. At 2 second, interesting thing happened. So this is then Fs max. What is Fs max? Fs max is 1. If anything bigger than 1, it drops. It drops, as you said many times in the classroom. It drops. It drops to where? It drops to 0.9. This is Fk. What we try to find is mu k. So Ff is equal to mu k Fm. So mu k is Ff over Fm. Of course, Ff is 0.9 and mu Fn is 2. So 0.9 divided by 2. Mu k is 0.45. All the physics studied this problem. The journey is 4 seconds long, 5 seconds long. 1, 2, 3, 4, 5 seconds long. And this is 2, 4, 6, 8. This is displacement in meter, and this is time in second. So many of you got it wrong, not sure why. 0 to 2 seconds, object moves with constant velocity 2 meters per second. 2 to 3 seconds, object at rest. 3 to 4 seconds, object moves with constant negative velocity, negative acceleration. 4 to 5 seconds, constant negative acceleration. So if acceleration is negative, then force is also negative from 3 to 5. From 3 to 5. The force cannot be positive. Net force cannot be, acceleration cannot be negative unless the force is negative. So net force and acceleration always at the same direction. Okay, so in the future I'll show you a different way. Today I'm just going to finish it. So the velocity versus time graph. So let's say the velocity is the velocity of this one is 4 divided by 2 is 2, and then 0 divided by 1 is 0, and then you have a, it's not, function is not continuous over here. the function is continuous, but it's not differentiable. So function is continuous, but it's not differentiable, meaning that there is a jump over here. Okay. So then this is Vt. We want to find this one, but this one is equal in magnitude with this one. If this one is whatever, this one is also that. We know this guy. We know 3.2. 3.2, this is 3.2. This velocity has to be positive. Why? Okay, because the slope is positive. So velocity is positive. Acceleration is negative. The force is negative. Velocity is positive. What is the velocity? Right here. Okay, so we know that d is equal to area is half bh. So this is displacement half. B is the time. 4 minus 3 is 1. H is the velocity. And displacement is 8 minus 4 is 4. So velocity is 8. If this one is 8, this one is negative 8. Okay, so that's good. So what is the here point here? Here is 3 comma 8. What is the point here? 5 comma negative 8. We want to find the slope. x1 y1 x2 y2. All right, so y2 minus y1 x2 minus x1, we're going to call it slope. Y2 is minus 8 minus y1 is 8. X2 is 5 minus 3 minus 16 2 m. So minus 8. We want to call it acceleration. Why is that? Because this is slope of VT graph. Slope of VT graph is acceleration. All right. Now we're going to use y equal to mx plus b. We have 2 points. Let's use this point. Y is 8. M is negative 8. X is 3 plus b. So b is 32. Now y is equal to mx plus b. So y is m is slope negative. Oh wow, let's use this one. I'm sorry for using this. Vf is equal to vi plus at. Vf, that's what we are find at 3.2. The y-intercept is 32 minus 8, 3.2. So the Vf is 6 point what? 6.4 meter per second. Now we're gonna find the force. Force is equal to ma. M is 12. A is negative 8. Some extra information which you don't need. The car is moving on a dry which is mu k is 0.6 I believe. All right, so the driver, someone crossing the road, and the driver hit the brake immediately. So then bi is not 0 here. Here he hit the brake. Here vf is 0. We don't need all of those things. All we need the mass, 1200 kilograms. Because I asked you to find, what did I ask you to find? Magnitude of friction force. So at this location, what is the free body diagram? Only one force acting at the x direction. Two other force acting at the y direction. This is Fg. This is 12000 Newton. Using negative 10 acceleration due to gravity. So Fn must be also 12,000 Newton. And this is Ff, which we try to find. So Ff is equal to mu k Fn. Mu k is 0.68. Fn is 12,000. So about 8,000 Newton of friction force. Okay, so that's test number 7. Test number 8 is going to be on Friday, December 20th. And that would be the last test for MP2. MP2 I give 4 tests, and that would be the last test. And the midterm is in January.